The average sausage takes just 45 minutes to go from raw meat to packaged product in modern factories. In this exclusive factory tour, we'll show you every surprising step that unfolds in those critical minutes. Have you ever wondered if your breakfast contains automotive-level engineering? You'll witness how sausage production operates with the precision of a finely tuned engine. The same engineering principles used in car manufacturing are applied to food, from sophisticated meat grinding systems to computerized quality control that inspects each link. By the end of this video, you'll never look at that package of sausages in your fridge the same way again. Ever wonder how many sausages actually come off a production line each day? The numbers might shock you. Modern sausage factories operate on a scale that's almost impossible to visualize, producing more links in 24 hours than most neighborhood butchers make in an entire year. Think about it. Feeding a nation requires industrial-level production. When millions of grocery stores, restaurants, and food service companies need consistent supply, traditional artisanal approaches simply can't match the necessary volume. This massive scale challenge demands revolutionary engineering solutions. Just as Henry Ford transformed car manufacturing by introducing assembly lines, sausage production has undergone a similar evolution. What skilled butchers once created by hand has transformed into precision manufacturing with computerized controls and specialized equipment. The production numbers are mind-blowing. A single modern facility running at full capacity produces enough sausages daily to stretch from New York to Philadelphia if laid end to end. That's roughly 100 miles of sausages. Imagine standing at the base of the Empire State Building watching this protein parade stretch all the way to the Liberty Bell. And remember, dozens of these facilities operate across the country simultaneously. These factories face the same fundamental challenge as automotive plants, maintaining consistent quality while hitting enormous production targets. Car plants can't compromise safety to build more vehicles, and sausage factories can't sacrifice food safety to increase output. The solution lies in engineering systems that handle raw materials at incredible volume while maintaining strict quality control. Temperature management becomes critical when processing tons of meat hourly instead of pounds. Even a small temperature variation, similar to how a slight shift in engine cooling can damage a car, could cause major quality issues when multiplied across millions of units. Each production line operates with precision timing systems familiar to anyone who's toured a modern car manufacturing plant. Conveyor systems move products through different stations at calculated speeds. Workers and automated systems perform specialized tasks with timing measured in seconds rather than minutes. The entire operation runs on a carefully orchestrated schedule where delays cause ripple effects throughout the facility. The engineering challenges don't stop there. Raw material handling requires specialized equipment moving thousands of pounds efficiently. Storage systems maintain ideal temperatures across massive spaces. Mixing and forming equipment creates consistent products from natural ingredients that vary batch to batch. It's a complex dance of mechanical, thermal, and control systems working in harmony. The largest facilities make over 3 million sausages in a single 24-hour period, about 2,000 sausages per minute rolling off the production line. This rapid pace means quality inspection systems must process visual data at incredible speeds while maintaining strict standards. Imagine counting to 2,000. That would take you several minutes. Yet in that time, another 2,000 sausages have already been produced. At this incredible pace, tiny inefficiencies become magnified. If a process wastes just 1 second per sausage, that's over 800 minutes of lost production daily, nearly 14 hours. This is why these facilities invest millions in specialized equipment designed to eliminate every fraction of wasted time or material. Those millions invested in specialized equipment aren't just for the assembly line itself. They're for what happens before a single sausage takes shape. Have you ever considered that the meat in your breakfast links has already gone through inspection technology nearly identical to what automotive manufacturers use to check engine components? When raw meat arrives at the facility, it enters what food engineers call the preparation phase, a hidden world of processing that transforms animal protein into a manufacturing ingredient. This isn't your local butcher trimming a few steaks. We're talking about processing rooms where forklifts move tons of raw meat through a series of increasingly sophisticated machines. Temperature management forms the foundation of this process. The entire preparation area maintains constant temperatures between 28 to 32 degrees Fahrenheit, cold enough to prevent bacterial growth while keeping the meat workable. These climate systems operate on principles similar to your car's engine cooling system, with thermostatic sensors that adjust cooling output to maintain that critical 1 to 2 degree window. Even a brief temperature spike could compromise thousands of pounds of product. The temperature stabilized meat then passes through optical scanning systems systems that resemble the high-resolution cameras in modern vehicle safety systems. These scanners employ multi-spectrum imaging to detect bone fragments, contaminants, and quality issues invisible to the human eye. Similar to how advanced driver assistance systems can spot hazards in poor visibility, these scanners detect fragments as small as 2 millimeters and thousands of pounds of meat processed hourly. Computerized weight management systems bring another layer of precision, monitoring the exact weight of meat components down to the gram. This precision allows factories to create consistent batches despite natural variations in raw materials, mirroring the exacting standards in fuel injection systems where precise amounts must be delivered at exact intervals. Next comes mechanical transformation, where recognizable cuts of meat become uniform material. Powerful hydraulic systems press meat through separation screens to remove unwanted connective tissues, while industrial grinders with computer-controlled blade speeds reduce everything to precise particle sizes. The grinding process isn't just about making meat smaller, explains food processing engineer Mark Jameson. It's about creating specific texture profiles that directly impact the final product's bite and mouthfeel. We can adjust blade speeds and configurations to create anything from coarse country sausage to fine emulsified hot dog. Throughout preparation, computerized systems continuously monitor temperature, moisture content, fat percentage, and protein levels. If any parameter drifts outside acceptable ranges, the system alerts technicians before quality issues develop, similar to how modern vehicles use dozens of sensors to continuously evaluate engine performance. The most surprising aspect is the level of computerization involved. Modern meat preparation facilities feature control rooms that resemble industrial command centers, with technicians monitoring multiple screens displaying real-time process data. These systems can trace any individual batch from receiving dock to final preparation, creating detailed records for complete product traceability. By the time meat completes this preparation phase, it has transformed from a variable natural product into a precisely engineered manufacturing ingredient with known properties. What was once simply meat has been inspected, temperature controlled, separated from unwanted components, ground to specific sizes, and nutritionally analyzed, now ready to become the sausage you'll eventually enjoy at breakfast. That precisely prepared meat is just the canvas. Now it's time for the artistry that happens in mixing chambers monitored as carefully as a chemical laboratory. The most crucial ingredient in creating that perfect sausage texture is water, added with precision that would impress aerospace engineers. Without this simple element, achieving identical products across millions of units would be virtually impossible. But why is something so basic so critical to mass production? Natural meat presents a manufacturing challenge with its wild inconsistency. Even cuts from the same animal vary dramatically in moisture, fat distribution, and protein density. These variations might add character at your local butcher shop, but they create nightmares when producing thousands of sausages per minute. The science of sausage formulation transforms this unpredictable raw material into a consistent product, much like how race car engineers take variable components and calibrate them into a championship-winning setup. In the mixing room, computerized batching systems measure ingredients with accuracy down to fractions of a gram. This precision rivals fuel injection systems in modern cars, where millisecond adjustments in spray patterns determine the difference between power and inefficiency. For sausages, this exacting science ensures every bite delivers identical flavor and texture from the first product to the millionth. Water addition follows strict mathematical formulas as a specific percentage of the total mixture. The parameters are unforgiving. Too little creates dense, dry sausages. Too much produces mushy products that disintegrate during cooking. This carefully calculated water serves double duty by carrying spices and seasonings throughout the mixture, guaranteeing flavor consistency in every bite. The spices themselves enter the mix through automated systems that detect weight variations smaller than a grain of sand. These systems maintain perfect ratios of garlic, pepper, and paprika across massive production runs, creating the signature flavor profiles customers expect with every purchase. Industrial mixers represent another engineering marvel. Their specialized paddles, designed using fluid dynamics principles, create precise flow patterns, ensuring even distribution without overworking the meat. While traditional butchers might mix by hand, these sophisticated machines maintain protein structures intact, compact, preventing the rubbery texture that ruins mouthfeel. Throughout mixing, sensors continuously monitor temperature and humidity, feeding data to control systems that make real-time micro-adjustments. When friction threatens to overheat the mixture, cooling systems activate automatically. If moisture levels drift, the system compensates before quality issues develop, much like how modern engine computers constantly fine-tune performance parameters. Modern sausage formulations also incorporate specialized binding agents and stabilizers. These ingredients solve consistency challenges across varying cooking methods, similar to how automotive engineers ensure tire rubber performs reliably in all conditions. The sausage must maintain its texture whether grilled over open flames or gently simmered in beer. Behind these formulations stand food scientists with advanced degrees working in laboratory-like test kitchens. They develop specifications as detailed as automotive engineering blueprints, quantifying everything from protein percentage to thermal expansion during cooking. These experts balance competing priorities including cost, flavor, texture, shelf life, and cooking versatility, creating products that perform perfectly from freezer to plate, regardless of preparation method or regional taste preferences, even accounting for seasonal variations in raw materials. With the perfect formula established, it's time to witness engineering precision at its finest. The machines that transform meat paste into perfectly shaped sausages operate with tolerances tighter than your car's engine, where even a 1mm variation could mean the difference between a premium product and thousands of dollars in wasted meat. These are sophisticated systems that cost more than some people's houses. The heart of the sausage forming process is the stuffing machine, a hulking metal beast worth upwards of $500,000. These industrial marvels use advanced hydraulic systems that force meat mixture through specialized nozzles at carefully controlled pressures. This maintains perfect density and eliminates air pockets that would compromise quality. Our high-pressure stuffers maintain significant force throughout the process, explains equipment engineer Sarah Mendez. We need that pressure to ensure consistent density throughout each sausage. Each stuffer connects to a linking mechanism that performs a mesmerizing transformation, creating individual sausages from a continuous meat tube. Like a precision automotive assembly line, these systems use optical sensors to measure exact lengths before specialized twisters create the characteristic links we recognize. Each twist occurs within milliseconds of the previous one, with seamless coordination reminiscent of robotic manufacturing. Once shaped to perfection, the next phase applies a chef's touch combined with engineering precision. The raw sausages enter multi-million-dollar continuous cooking systems that create calculated temperature gradients throughout the product. We've designed our cooking systems with multiple distinct temperature zones, notes thermal engineer James Wilson. Each sausage progresses through specific heat profiles that develop flavor while ensuring food safety, similar to how your car's engine management system precisely controls combustion temperatures. These cooking tunnels stretch longer than a semi-truck, containing computer-controlled heating elements that adjust in real time. The system compensates automatically for changes in ambient humidity or if a batch enters with slightly lower temperature. Cooking time variances are measured in seconds, with deviation of even 15 seconds potentially affecting texture and quality. Throughout the process, thermal imaging technology monitors everything without contact. Infrared cameras scan thousands of sausages per minute, measuring internal temperatures with the same precision your car's sensors monitor critical systems. This ensures every sausage reaches food safety thresholds without compromising texture. Inside the control room, operators watch touchscreen displays showing real-time data of sausages moving through the system. Color-coded thermal maps indicate internal temperatures, while predictive algorithms calculate optimal doneness times. The entire forming and cooking process operates as a synchronized dance of mechanical systems. If one component changes speed, everything else responds accordingly. What makes this process particularly impressive is how these machines handle natural variations in meat mixture. Unlike manufacturing with consistent materials, sausage production deals with biological ingredients that change batch to batch. It's actually more challenging than many manufacturing processes, explains automation specialist Kevin Jang. When you're making car parts, your raw materials have consistent properties. With food, we're constantly adapting to natural variations while delivering a product that looks and tastes identical every time. These sausage forming and cooking systems represent millions in investment, combining high-pressure systems, precision timing mechanisms, thermal regulation, and computer control worthy of modern manufacturing. They transform tons of meat mixture into perfectly uniform products at a scale unimaginable decades ago, all while maintaining the consistency consumers expect from their favorite brands. The moment a sausage exits the cooking system, it enters what might be the most critical phase of production: quality control. When a facility is cranking out thousands of products per minute, traditional inspection methods would be like checking your engine with a magnifying glass while racing down the highway at 100 miles per hour. Utterly impossible. This is where automotive-inspired technology becomes the unsung hero of food safety. Consider the math for a moment. At a facility producing 2,000 sausages per minute, a seemingly excellent 99.9% detection rate would still allow 2 potentially contaminated products to slip through every minute. That's 120 per hour, or nearly 3,000 per day. Numbers no manufacturer could accept. The solution? Multiple layers of inspection technology that operate with the same precision and vigilance as modern vehicle safety systems. The first line of defense combines metal detectors and X-ray systems that work in tandem like your car's collision prevention suite. The metal detectors identify particles as small as 0.5 millimeters using electromagnetic fields, while X-ray machines peer through the product to spot internal abnormalities. Both technologies sharing core principles with automotive safety sensors that can detect a pedestrian or vehicle in your blind spot before you even know they're there. Our detection systems operate with a zero-tolerance approach, explains food safety specialist Dr. Sarah Chen. The scanning systems process data from thousands of products per hour, making split-second accept-reject decisions on each one. Imagine technology so precise it can spot a paperclip in a sausage faster than your car's emergency braking can detect a child running into the street. Weight verification stations add another crucial layer, operating with accuracy down to 0.01 grams, even as products travel at speeds up to 500 feet per minute. These high-precision scales mirror the exacting standards used in automotive components manufacturing, where a fraction of a gram difference in a critical part could mean the difference between safety and failure. The automated inspection systems handle the routine scanning of every product, which allows our quality specialists to focus on higher-level analysis and system monitoring, notes quality control engineer Marcus Powell. It's a partnership between human expertise and machine precision. Laboratory testing completes this multi-layered approach, with automated sampling systems pulling products at statistically significant intervals for microbiological testing and compositional analysis, a methodology refined through decades of automotive quality assurance programs. What truly elevates this system is its integration. Every batch of sausages generates a comprehensive digital record tracking everything from raw materials to cooking temperatures to inspection results. The digital tracking system is comparable to the diagnostic data logging in modern vehicles, explains food technology consultant Elena Rodriguez. Just as your car's computer records performance metrics and fault codes, our production systems maintain comprehensive records of every parameter affecting product quality and safety. The response time to detected issues is particularly remarkable. When contamination is identified, the affected product is ejected within milliseconds using high-speed air jets, a reaction time that rivals even the most advanced vehicle accident avoidance systems. Production continues uninterrupted while the rejected product is isolated for analysis. These redundant systems create a safety net far more comprehensive than most consumers realize. Every day, millions trust both their vehicles and their food with their lives, rarely considering the parallel technologies keeping them safe. From electromagnetic scanning to X-ray visualization to microbial testing, each sausage undergoes scrutiny comparable to automotive safety components, a silent partnership of technology and expertise that protects us daily in ways most of us never see. So next time you see a sausage at your cookout, you're witnessing the culmination of a journey from farm to plate that would impress any automotive designer. From high precision weight measurements to thermal imaging technology, these facilities represent the hidden engineering marvels behind everyday food. The humble sausage undergoes more quality checks than most vehicles on assembly lines. Just as every gear in your car works in harmony to deliver a smooth ride, every sensor and machine in these factories ensures your meal is both safe and delicious. If you found this peek behind the curtain fascinating, hit subscribe for more videos exposing the incredible engineering behind everyday items. There's a whole world of industrial innovation hiding in plain sight, and we're just getting started.